Good afternoon, everyone. So today I'm going to talk about also intellectual property as how we integrated ChemAxon tools in orbit chemistry. So I'll tell you a little bit about Questel, the company I work for. So we are a company in intellectual property. We started in 1970, and we were among the first patent data provider before the time of internet, actually, providing data via Minitel and Technique that we had in France at the time. And since then, the company has grown and evolved, and now the aim is really to cover the whole process in IP, from the idea, having an idea of a molecule, how do you protect it, what you want to, the workflow you would have with managers and so on, to discuss how to, maybe patent it or publish it and so on, all the way through protection, filing a patent, and then how to monetize your asset, perhaps where you have discovered you don't intend to commercialize it, maybe you want to have a license for your patent and so on. So it's really the whole cycle of intellectual property. We are now a little over 200 people and we are based worldwide. And from a software company, we are also branching out into services, and I will touch upon briefly. So first, these are our core software. So the main software is a patent database, and I will show you today how we integrated ChemAxon tools within the patent database. And then we have other tools, which are patent database for R&D, which is, let's say, easier because you don't have all the legal aspect of opposition and lawyer and so on. And Orbit Intellixir, where this is more for data scientists, where you can also integrate non-patent literature and monitor your competitors, search for innovation, technology watch, and so on. More tools I won't discuss as other parts of intellectual property, such as managing your asset, having a reminder where to file, and how to optimize your budget, your IP budget, and so on. So it's different tools where we haven't implemented the chemistry, so I won't discuss it today. The second part of the company, and it's quite a big part now because it represents a quarter of the company, so over 50 people worldwide. We have consultants which can help doing freedom to operate, state-of-the-art, and all various research for you. And they use, of course, all the chemistry tools that we develop, and we develop them with them. So I won't go through the slide, it's just to tell you that over the last 20 years, we have, of course, evolved from being a patent database. We have integrated more and more data, and we are always keen to understand how can we make searching into patent easier, how can we make reading patent easier. And so now we have extracted over 9 million chemical structures, and we have over 15 million patent documents indexed. So the way we have done the chemistry module is that we have fully integrated it in our software. It's very transparent for the customer. You can combine a search. So when you would typically search for patent of a specific assignee after a specific year with keyword, you can now include a molecule search where you can search for a specific drug or UPAC name or whatever synonym. And behind we will have a ChemAxon module plus our search engine retrieving the corresponding patents. So one of the advantages is that you can search, for instance, for aspirin. And of course, it will retrieve patents that contain acetylsalicylic acid. We have used the exact architecture that Daniel presented at the beginning, which means we have taken our whole patent database. We've used tools such as name to structure to extract all the molecules. We created our database, and then you can use GChemBase to search in this database, making it much easier for users to just enter one chemistry name and we retrieve all the variation of the name. Here is to show that we have implemented the document annotator, and it's very practical when you see a patent like this. You can be a great chemist. It's a nightmare to have to read each and every line and trying to understand what is attached to the 6 or the 5 and trying to reconstruct. It's so much easier to just hover over it and have the structure shown, and you can see where the various substitutions were they're made, and so on. So here in yellow correspond to the substructure of search, of course. Of course, to do any substructure search or drawing search, we have implemented the MarvinGS editor, where you can draw your molecule. And a function that we particularly appreciate of MarvinGS, and I don't think it's been discussed over this meeting, is that when users create their structure, they can save it and have a library on their computer, and then they can just re-import it. And that's really appreciated. So I don't know if it will work. This is a quick video. I don't know if maybe you need to... If I press, OK, it starts. So this is just to show you how we work and how it's been integrated. You can just here have the ChemAxon, MarvinGS. You can either draw or import a structure that you have, and that will be quite a common way to have your little library and to import a mol file or an MRV file. And this is a fairly simple molecule. It's a 5-membered ring. However, here when we do the substructure search, of course, we can generate all the possible molecules. And from all the possible molecules, we can find all the possible names. And the names are usually very difficult to use in patent database, since they have all the special characters, inverted commas, and so on. And so you can see that here it retrieves just under 2,000 patent families, because we work in families, so it's more than patents. And quickly you can see that it is a cosmetic compound that I've searched. Actually, the top actors here are L'Oreal. And here you can see for the various members of the family quickly the head. You have on the side the top assignees. And quickly see here I've clicked on Henkel to find the patents that were published specifically by Henkel, to analyze what they've been doing and how my query hit their patent. So again, if you look through the titles, you'll see it's also in the cosmetic fields. And by hovering over it, you can rapidly see exactly where were the point of substitution and where are the differences. Something that is, of course, important that you discussed in the previous talk is that here is nice to be able to see in which member of the family has been discussed, so WUS, or in the claim directly going into the highlight to find, OK, but what are the molecules that are claimed right here, right now, and to be able to identify where they are discussed in description, in claims, and how do they match to my to what I'm interested into. OK. OK, so this is for the patent database. That's what we implemented to search and visualize. This is just to give you a brief background. So we have limited our indexation to technological domain to avoid having noises or trade names that could be used in other fields. And we have limited to the geographic coverage that I discussed here. And basically, our indexation is as good as name-to-structure technology, having the possibility to have all the synonyms. The one that we couldn't index is Cas number, so I'm really pleased. I've heard Daniel's presentation, where he mentioned that apparently there has been improvement with Cas. We couldn't index because of the web service, so that's really good. OK, the second software in which we have implemented ChemAxon modules, so we use exactly the same technology. We extract the molecule from the documents, we index it with GChemBase, and then we make it searchable using MarvinGS or Document Annotator. But this time is for advanced analytics. And it's not just on patent data, it's on whatever you import. So you can import article, clinical trials, in-house Excel files, and you can then analyze chemicals. So I'm just going to show a video so it's quicker and easier. So here I have imported patents and articles, and the software directly extracts the top molecules. And it's very clean because obviously it's only one name and you don't have all the synonyms. I can quickly plot it against assignee and see who is working on what kind of molecule and rapidly have an idea of the field I'm studying. And here, if you want to customize it, you can actually choose the type of molecule you want to analyze. So you create your own core structure. Here's a prednisolone core structure, and lists various core that can be of interest to you to then run the analysis to see how many documents you have per interesting core structure. Then you can plot it over time. Is there a structure that is having growing interest in the literature? You can, of course, plot it against assignee and see in your core structure and what you're interested into, who is in the same field. Is there like a new player with only a few documents in the field, or are they known players? Again, you can plot it against inventors if you're wanting maybe to hire someone who has a field of expertise in the type of molecule that interests you. And sometimes it can be nice as well to manage to find the documents that are talking about a combination of molecules that are of interest to you. And here to quickly say, okay, these are the group I'm interested into, and I want to find the documents that will talk about the three type of compound at the same time. And I think here is my final example where I can plot the type of molecule against application. So I could define any application. Here I've chosen a simple list. And this can be good for search for innovation, where you have typical, let's say, prednisolone core structure, and you think you have, you know the application, and here you see something similar in psoriasis. You might want to investigate and see if you can have new application for it, and really exploring your data. And it's really about getting your patent, your non-patent literature, and looking in different angles to see if you can see something interesting. Okay, so this is a brief summary of, we have successfully implemented ChemAxon module in both Orbit Chemistry Intelligence, Orbit Intelligence and Orbit Intellixir. And we are happy to say that it's now fully done. What we like most as Questel is the fact that ChemAxon doesn't rely solely on titherite, the fact that you have an algorithm that allows us to detect chemicals in patent almost immediately. By that I mean the fact that you can read a chemical name and create the structure. It means that for us, a patent that is published on Thursday can be searchable in our database on a Sunday. So we are very fast to retrieve the patent, so that's really a key point for us. Our future plan is to expand our chemistry module further, maybe try and see if we can expand without introducing too much noise, by expanding perhaps the coverage beyond classification or more countries, improve as well our reading help, such as maybe improving a highlighting function where you can draw what you want or just what you searched. And this is funny because I was going to say I hope to see a name to structure expand, but it's already been done, so the cosmetics are already done and so much is on the way, so it's good. It's perfect. And just before the last slide, I want to thank ChemAxon. It's really a beautiful event. I can only imagine how much effort it required to organize such a beautiful venue, beautiful decoration. It's always a great pleasure to be here. And I think everyone, thank you for the effort you put in the annual meeting. And thank you for everyone for listening.